Have you ever thought about what makes a planet, a planet?
Mm,
Is it just how big it is? Or is there something more to it?
right.
Well, today we're diving deep into this whole world of planets.
Yeah.
We've got the familiar ones in our solar system, but then some really out there planets you wouldn't believe.
Yeah, some really exotic ones out there.
Welcome to Cosmos in a Pod, Space and Astronomy Series. Get ready to go way beyond the simple definition of a planet.
Yeah.
We're going to explore how astronomers actually classify all these crazy different worlds out there.
A question that's really puzzled astronomers, I mean, for centuries, really.
Let's start with our own solar system.
Okay.
Remember back in 2006, that whole Pluto thing
Oh, yeah.
that really stirred things up? What happened there?
So the International Astronomical Union, the IAU, they decided we need a stricter definition for what is actually a planet.
Okay.
So they came up with three key criteria.
All right.
First, it's got to be orbiting the sun.
Yeah.
Second, it needs to be round, or at least nearly round, because of its own gravity. Basically, it has to be massive enough for gravity to pull it into a round shape.
Okay.
And third, and this is the tricky one, a planet has to have cleared its neighborhood.
Cleared its neighborhood. What does that even mean?
So it means that a planet has become the dominant gravitational force in its orbit, right? It's either swept up or flung away most of the other objects in its path.
Oh, okay.
And this is where Pluto fell short.
Yeah.
It shares its orbital space with a whole bunch of other icy bodies in the Kuiper belt.
So Pluto got demoted because it's not like a gravitational bully, so to speak.
You could say that. I mean, it's more about gravitational dominance, and this definition, it works pretty well within our solar system. But when we start talking about exoplanets, planets outside of our solar system, things get a bit more complicated.
I can imagine. Why is it harder to classify exoplanets?
Well, it's really tough to observe those distant planetary systems in any detail. I can't always tell if a planet has, cleared its neighborhood or not.
That makes sense. So how do we even begin to classify those distant worlds then?
Well, we rely on what we can observe, right? So their mass,
Yeah.
their size,
Right.
their composition, how far they are from their star. This gives us some clues about their structure and what they might be like.
So let's break down these different types of planets that are out there.
Oh, right.
So we've got the familiar ones in our solar system.
Right.
You've got the rocky terrestrial planets like Earth, Mars, Venus, Mercury.
Right, and of course, Earth is the archetype here. It's the only one we know of so far that can support life.
Right.
And then you have the gas giants, Jupiter and Saturn. Massive planets composed mostly of hydrogen and helium.
And then there's the ice giants, Uranus and Neptune, with their unique icy compositions.
Exactly. Each type of these planets, they have their own special characteristics that help us classify them.
But then things get really wild when we step outside of our solar system.
Right.
We start to find these planets, these types of planets that we don't even have here. Like, tell me about these super Earths and mini Neptunes I've been hearing about.
Ah, yes. Those are categories that are specific to exoplanets.
Okay.
Super Earths, as the name suggests, they're rocky planets, but they're bigger than Earth, but smaller than Neptune. And then mini Neptunes, they're like smaller versions of Neptune, but they have these thick atmospheres.
These sound fascinating.
Oh, yeah.
Can you give me some specific examples of those?
Sure. There's a Kepler 452b.
Okay.
It's a super Earth. It orbits a star, very similar to our sun.
Yeah.
And it sits within the habitable zone. So that means it might have the right conditions for liquid water to exist on its surface.
Wow. A potentially habitable super Earth. That's incredible.
Right.
What about mini Neptunes?
One really interesting one is TOI 270c. And studying this mini Neptune, it's helping us understand the transition between rocky planets and gas giants.
So we're learning a lot about planet formation from these distant worlds.
Oh, yeah.
And then there are rogue planets.
Right.
These are planets that aren't bound to any star.
Right, yeah.
And they just kind of drift through space.
Yeah, they're just cruising through the galaxy all by themselves.
Rogue planets. They sound like lonely wanderers of the cosmos. How do they even form?
Well, they were probably ejected from their original solar systems when they were
Oh,
forming,
wait.
maybe through gravitational interactions with other planets. One example is PSO J318.522. It's a rogue planet discovered back in 2013.
It's amazing to even think about. So how common are these rogue planets?
It's hard to say for sure, but they might be more common than we think.
Oh, yeah.
They're just incredibly difficult to detect
Right.
because they don't emit much light.
Okay, so we've covered the familiar, the somewhat familiar.
Yeah.
Now I'm ready for the truly weird stuff. Bring on the exotic planet types. What are like some of the strangest planets out there?
Oh, get ready for some wild ones. So there are ocean worlds.
Okay.
These are planets completely covered in water. Think of a planet-sized ocean.
Whoa. Are there any real examples of those?
Well, there's Europa. It's a moon of Jupiter, and it's thought to have a vast ocean beneath its icy surface.
Okay.
And there's GJ1214b. It's an exoplanet, and it shows strong evidence of being an ocean world. Imagine the possibilities for life in those environments.
It's mind-blowing. What else is out there?
Then you've got lava worlds.
Okay.
Planets so close to their stars that their surfaces are just molten rock. 55 Cancri E is a scorching example of
This sounds incredibly harsh. How do scientists even study a place like that?
It's a challenge. They have to rely on observing the planet's light and how it interacts with its atmosphere to try to learn about its composition and temperature. It's like trying to study a volcano up close.
Wow, that's intense. What other bizarre planets are on the menu?
Well, there's the hypothetical carbon planet.
Okay.
It's a world that's rich in carbon. Some scientists think that these planets, they could have surfaces made of graphite or even diamonds.
A diamond planet. Now, that's something I'd like to see.
Yeah.
Have we actually observed one yet?
We haven't observed one yet.
Or
The
not.
theory is that they could form in star systems that have a higher carbon-to-oxygen ratio than our own.
Okay, so maybe there's a whole blinged out solar system out there somewhere. What else we got?
How about puffy planets? These are gas giants that are incredibly inflated because of the heat from their star. HAT P67b is a good example.
Buffy planets, lava worlds, diamond planets.
Uh-huh.
This is wilder than any science fiction movie I've ever seen.
Oh, I know, right? It's mind-blowing. And then we have tidally locked planets. So this is where one side permanently faces the star.
Right.
And it results in these extreme temperature differences.
So eternal day on one side, eternal night on the other. What would it even be like to live on a planet like that?
Oh, it would definitely make for some unusual weather patterns.
Yeah.
TRAPPIST-1m is a tidally locked planet.
Okay.
And it falls within the habitable zone of its star. So it's a really intriguing target for study.
All these incredible discoveries must keep astronomers busy. So how do they even find and classify all these exoplanets in the first place?
There are three main methods. There's the transit method.
Okay.
There's radial velocity and direct imaging.
Okay.
The transit method is the most commonly used one.
Right.
It involves looking for these tiny dips in a star's brightness as a planet passes in front of it.
Okay.
Kind of like a mini eclipse.
That sounds pretty ingenious. What about radial velocity?
So radial velocity, that measures the wobble of a star caused by the gravitational pull of an orbiting planet.
Ah. So we can detect planets even if we can't see them directly.
Exactly, yeah. And then there's direct imaging. And that's literally taking a picture of a planet.
Wow.
But it's incredibly difficult.
Yeah, not bad.
Because planets they're so much fainter than their stars.
Yeah, I can imagine that's quite a challenge.
Yeah.
What are we hoping to learn from directly imaging exoplanets?
Oh, direct imaging, it can give us information about a planet's atmosphere, its temperature, and it might even allow us to search for signs of life.
This is all so fascinating. But with so many new discoveries, there have to be some areas where our understanding is still evolving, right?
Oh, absolutely. One of the biggest ongoing debates is where we draw the line between planets and dwarf planets.
Right.
There are objects out there that blur the lines, and it makes classification tricky.
I guess the more we discover, the more we realize how much we still don't know.
Exactly. And that's what makes this field so exciting. There are still so many unanswered questions about the universe's incredible array of planets.
We've covered a lot of ground here. I'm definitely ready for a little break to let all this new information sink in.
Me too. But stick with us because when we come back, we'll be diving even deeper into the mysteries of exoplanets and the search for life beyond Earth.
And don't forget to follow Cosmos in a Pod and subscribe to our YouTube channel for more exciting deep dives into the mysteries of the universe. We'll be back soon with more fascinating insights.
Welcome back to Cosmos in a Pod.
So we've been talking about all these different, types of planets, but I'm kind of curious, are these classifications always so clear-cut? Are there like any cosmic objects that just don't fit neatly into those categories?
Yeah, that's a great question. And it really shows how our understanding of the universe is always changing, right?
Right.
Take brown dwarfs, for example.
Yeah.
They're fascinating. They kind of blur the line between planets and stars.
Brown dwarfs. I've heard that term before, but I'm not really sure what they are.
You can think of them as like failed stars.
Okay.
They're bigger than giant planets, but they're not quite massive enough to sustain nuclear fusion in their cores, which is what powers, stars.
So they're kind of stuck in this awkward in-between phase.
Exactly. They're in this cosmic middle ground, and their classification, it's been debated for years.
I can see how that would be a headache for astronomers. What makes them so hard to categorize?
Well, their size and mass are big factors. I mean, they can be as small as some giant planets, but they can also be, much bigger. And their composition can vary a lot, too.
So how do we tell if we're looking at a brown dwarf or just a really big planet?
It's not always easy. Astronomers have to look at things like their temperature, their luminosity, and whether they show any signs of nuclear fusion, even if it's just, a tiny bit.
It sounds like a real cosmic detective story, trying to figure these things out.
Oh, it really is. And it reminds us that the universe is full of surprises, and our understanding of it is always being refined as we make new discoveries.
Speaking of refining our understanding, I've been thinking about that clearing its neighborhood criterion for planets.
Right.
It seems like that rule could be kind of subjective, especially when we're talking about exoplanets that, we can't observe as clearly.
Yeah, that's a really good point. And you're right, it's a point of a lot of debate among planetary scientists. There's actually a growing movement to reconsider that criterion or maybe even, get rid of it completely.
Really? Why is that? What are the arguments against it?
Well, for one thing, it's just really hard to apply consistently. As we talked about earlier, it's much harder to observe distant exoplanetary systems and know for sure if a planet has truly cleared its orbit.
So it's kind of biased towards planets in our solar system that we can, see better.
Yeah, some scientists argue that that's the case. They think a planet should be defined by its own properties, like its mass, its size, its composition, not by what's going on around it in its orbit.
That makes sense to me. I mean, a planet's a planet regardless of its neighbors, right?
Exactly. And focusing on those intrinsic properties might actually allow us to classify more objects as planets, including some that are currently considered, dwarf planets.
So we're talking about a potential Pluto comeback. Justice for Pluto.
It's a possibility. The debate's still going on, and there's no clear consensus yet. But it's a really cool example of how our understanding of planets is constantly evolving.
This whole planet classification thing is way more complex than I ever realized.
It really is. It's like a reflection of the incredible diversity of the universe itself. There are so many different kinds of worlds out there, and we're really just starting to scratch the surface.
Yeah. It makes you wonder what other strange and wonderful planets are out there just waiting to be discovered. What new technologies are astronomers using to kind of push the boundaries of our understanding?
Well, the James Webb Space Telescope, it's been making some incredible discoveries since it launched.
Right.
Its instruments are so powerful, they let us study the atmospheres of exoplanets in more detail than ever before.
That's right. I remember those stunning first images from Webb.
Yeah.
But how does studying those exoplanet atmospheres actually help us understand them better?
You can think of it like taking a planet's fingerprint.
Okay.
The composition of an atmosphere can tell us a lot about a planet's history, how it formed, its potential for life, and maybe even whether it shows signs of life already.
So we could potentially detect signs of life on other planets just by analyzing their atmospheres.
Yeah.
That's the hope. We're looking for what we call biosignatures. So those are gases like oxygen or methane that could indicate there's some kind of biological activity going on.
That would be groundbreaking. Are there any planets that are particularly promising for finding those biosignatures?
Absolutely. The TRAPPIST-1 system is one that has a lot of scientists excited.
Okay.
It's a nearby star system with seven Earth-sized planets.
Wow.
And 3 of those are in the habitable zone.
7 Earth-sized planets.
Mm.
The possibilities are mind-boggling. What else is coming up in the world of exoplanet exploration?
There's some really cool missions in the works. The European Space Agency's Plato mission, for example. It's designed to find and study Earth-like planets around stars like our sun.
So potentially finding more planets that could be like our own.
Exactly. And then there's NASA's Nancy Grace Roman Space Telescope. That one's going to have a wide field of view, which will let it search for exoplanets using a technique called microlensing.
Microlensing. That sounds interesting. What is that exactly?
It's a little complicated, but basically it uses the gravity of a star to magnify the light from a more distant star.
Okay.
And if there's a planet orbiting that closer star, it can cause a blip in that magnified light.
So it's like using gravity as a cosmic magnifying glass.
Precisely. It's a really powerful technique for finding planets that are further from their stars or planets that are just too small to detect using other methods.
It sounds like the future of exoplanet discovery is
Yeah.
incredibly bright. But before we get lost in all the excitement, I think it's time to kind of shift gears a bit.
Okay.
We've talked about the science of planet classification, the search for life, and the amazing technology that's helping us make those discoveries.
Yeah.
But what about the ethical side of space exploration? It seems like there's some big questions we need to be asking as we venture further out into the cosmos.
Yeah, you're absolutely right. As we explore the universe and potentially even encounter extraterrestrial life, we need to be thinking carefully about our responsibilities. It's a conversation we need to start having now, before we actually face those challenges head on.
Yeah. I'm definitely intrigued and maybe a little nervous to delve into those ethical considerations.
It's understandable. We're talking about potentially encountering, life as we don't know it, and that raises all sorts of questions about how we should interact, what our responsibilities are.
This deep dive has taken us from the familiar planets in our solar system to the most bizarre worlds imaginable, and now to some really profound ethical questions. I can't wait to explore this next chapter.
Me neither. Join us after the break as we contemplate the philosophical implications of our journey into the cosmos.
And remember to follow Cosmos in a Pod and subscribe to our YouTube channel for more exciting deep dives into the mysteries of the universe. We'll be right back.
Welcome back to Cosmos in a Pod.
So we've been on this incredible journey, exploring all these different planets across the universe. But now let's think about something a bit deeper, like the ethics of it all, the ethical side of space exploration. It's exciting and kind of daunting at the same time.
It's definitely something we need to think about carefully as we go further out there. The chances of us actually bumping into extraterrestrial life, well, they become more real, and that brings up a whole bunch of ethical dilemmas that we need to be ready for.
Like what kind of challenges are we talking about? What are some examples?
Well, one of the biggest worries is contamination. Like, if we send probes or even people to other planets, there's a chance, right, that we could accidentally bring Earth microbes with us.
Right.
And those could be harmful to any life that might already be there.
So we could accidentally wipe out alien life before we even know it exists.
It would be a huge loss, scientifically and ethically.
Yeah.
And then there's also the flip side. We got to think about those extraterrestrial organisms potentially contaminating Earth. We don't know how our biosphere would react to alien life.
It sounds like something straight out of a sci-fi movie.
I know, right?
But it's a real possibility we need to consider. What are scientists doing to try and minimize those risks?
Well, planetary protection protocols.
Okay.
Those are like a super important part of any space mission.
Right.
Probes and spacecraft, they go through this intense sterilization process to reduce the risk of contamination.
So it's like washing your hands before dinner, but on a cosmic scale.
Exactly.
Okay.
And there are very strict rules for for handling any samples that come back from other planets, like the Mars Sample Return mission, for example.
Yeah. Yeah, makes sense. Better safe than sorry, especially when we're dealing with, things we don't even understand.
Yeah.
But what about if we actually do find intelligent alien life? Like how do we even begin to talk to them, to interact with them?
Oh, that's where things get really tricky. There are a lot of discussions happening right now about how to create a universal language or some kind of protocol for communicating with extraterrestrial intelligence.
I mean, it's hard enough to communicate with people from different cultures here on Earth.
Yeah.
Imagine trying to bridge that gap with beings from a whole other planet.
It would be an immense challenge. We'd have to completely rethink how we understand language, how we communicate.
Yeah.
And then there are the questions of rights and responsibilities. Do extraterrestrial beings have the same rights as humans? How do we make sure they're safe? What if their values, what if their goals are totally different from ours?
It's like a whole new frontier, not just in science, but in ethics and philosophy too.
Absolutely. It's crucial to have these conversations now before we're, actually in these situations. We need to approach space exploration with responsibility and respect for the universe and everything that might be out there.
I couldn't agree more. This deep dive has really changed how I see exploring the cosmos. It's not just about scientific discoveries. It's about understanding our place in the universe and our responsibilities as citizens of the cosmos.
Well said. It's a humbling and awe-inspiring endeavor. It really requires careful thought and consideration.
It's been an amazing journey, going from those familiar planets in our own solar system to the most bizarre worlds we can imagine. And it's clear we've only just scratched the surface.
The universe is full of wonders, just waiting for us to discover them. Who knows what incredible planets and life forms are out there?
It's truly mind-blowing. Well, that's all the time we have for today's deep dive into the world of planets, but the exploration continues. Don't forget to follow Cosmos in a Pod and subscribe to our YouTube channel for more exciting deep dives into the mysteries of the universe. Until next time, keep looking up and never stop exploring those wonders of the cosmos.